Hi, Proof. Glad to have the chance to introduce our project. And our topic is flight price prediction. Our presentation is divided into 4 parts. First, I would give a brief introduction of our background, and Zhengyi Baicheng will introduce data preparation and visualization. As third part, Ishmita Zhengyi will explain and evaluate our models. At the final part, Jyoti will put forward some applicable business solutions. Also, COVID has made us fly less, but people who frequently travel will know that the flight prices vary frequently. For the business purpose, airlines change prices according to many factors like destinations, seasons, and so on. In this case, from the passenger view, it's difficult to find the perfect time to buy the tickets because they get very little information on future price rates. From the airline's view, they also want to know the price fluctuations across markets so that they can make best strategies. Our team aims to predict the flight price by machine learning models. If the travel website equipped with a flight price prediction tool, they can benefit the travelers better manage their travel plans and reduce the cost. And they can also cooperate with airlines to make price plans and tailor their products. Then I will pass to Zhengyi to introduce next part.
Thank you, Shihui. For the data preparation part, first we used one of the latest datasets from Cargo that includes 12 columns such as airline, departure city and time, arrival city and time, dates before takeoff, and so on. Second, we cleaned the data by dropping rows that contains missing values and outliers. At last, we created dummy variables for the following regressions. Moving on to the next slide. And here we have the description of the numerical variables of our dataset. So price is our target variable and it varies a lot. So we also apply this score to standardize the values. And to tell you more about our dataset visualization, please welcome Robbie.
So for this part, I have a plot about the distribution of the flights. So as you can see, there are two peaks. It's mainly because some company have the economic class and business class. For example, Vistra and Air India. So I slipped them into the economic class and the business class. For the economic class, most of the prices are below 10,000, and for the business class, the prices are among 40,000 and 70,000. So for the next page, here are some PowerPoint, here are some plot about each variables. For the first one, I draw a bar plot between the price and the companies. So as you can see, the Vistra and Air India have the highest price. And for the next two plot, is the scatter plot of the price and duration and the days left and the price. But unfortunately, we will not get a very clear relation between this kind of variables. And for the next part, I draw a plot about the price, destination city, and arrival time. So we can easily discover that the arrival time of evening will have the highest price. And so the same principle can apply on the price, departure time, city, and departure time. So from the data visualization, we can get some correlations about the each variables, but it's not very clear. So we need a further investigation. So my teammates will introduce the model part and the assessment part.
Moving on to the next part, which is model configuration and evaluation, we have used 6 different models for our business project. And the measurement for accuracy is root mean square error, mean absolute error, and R2 score. We have dropped the flight code column because even Orange 2 recommends not using variables greater than 100 categories, and this particular column had 1500 categories. The first slide, which is on the linear regression, shows the outcome of the model. So the verdict is that this is the least suitable model for our business because the RMSE value is quite high, which is 6719. This means that we are on an average INR 6719 away from the actual price, which would not be trust in our customers and affect our business performance. The graph on the left is the line trend graph. And as you can see, it does not clearly overlap. That is the actual and the predicted value. So it's not suitable. On the right, we have the scatter plot, which shows the predicted value against the actual price. Again, there is no clear linear regression line, not making it suitable. Moving ahead to the next, which is the decision tree. This has further dropped in terms of the RMSE value. And on the left, you can see there is a clear overlapping. And on the right also, the line looks a bit clearer, making it better than linear regression, but not the best model. Moving ahead to the random forest model, the RMSE value has further reduced to 2723. And this is fairly acceptable because the business class airfares are quite high. The left overlapping is quite well. And there is a very, very clear linear regression line on the right in the scatter plot, making this the most suitable model for our business project. Now, Jengi will take over for the other models. Thank you.
Okay, thank you, Ishimita. So we have used more models to predict price value, but sadly, none of them had a better result than random forest. The result of XGBoost comes closest to that of the random forest. And moving on to the next slide. For Keras, we can see from the plot that the loss gradually decreases with more epochs, but still Keras is not a good model because its root mean squared error is still very high compared to random forest. And moving on to the next slide. And here is our model comparison part. These two line graphs show the testing result from sklearn and Orange3. And with the highest R-squared score and lowest RMSE, random forest has the best performance in both Python and Orange3. And in addition, we can see the model results from Python are all better than that from Orange3. And last, for the business solutions, here's Jyoti to tell you more about it.
Thank you, Justin. Now it is known that flight prices can change up to 7 times in a single day, and this fact benefits no one. It discourages sales and leads to lower revenue. So our proposed solution is that airline companies partner up with travel agencies and websites. This way they can leverage on economies of scale by offering group discounts and packages. Our predictive tool can help identify customer preferences like the hot destinations and months for travel. Can we go to the next slide? Agencies can then come up with more deals to target a wider market. They can even offer discounts on loyalty schemes and mile points. The airline benefits by reducing costs in their marketing campaigns and at the same time getting better revenue forecast using a tool to chart sales. On to the next slide, please. Customer also benefits by getting more and better deals and lesser uncertainty. And with this, we conclude our presentation. If you have any questions, feel free to reach out to us. Thank you.